So now we're going to talk about action potentials, which is a regenerative electrical signal that's all or nothing. It's important to look at some definitions, and we can see here that we have the membrane potential, Vm, on the y-axis, and we just have time over here on the x-axis. We'll have this in milliseconds, although we're not going to be using that here for these definitions. Now notice that the membrane potential at rest, if we're considering a normal conditions where we have sodium and potassium considerations, we see that the EK is a negative value. That's always true if we have a high concentration of potassium on the inside of the cell relative to the outside, and we have a positive equilibrium potential for sodium, assuming that the sodium concentration is higher on the outside than the inside. And the reason why the V rest here is close to the equilibrium potential for potassium is because of the high potassium conductance or permeability at rest. The Goldman equation tells us that these will be close together. Now, at rest, this membrane potential being here is considered to be polarized. Now, when the membrane potential becomes less negative and the membrane potential increases, becomes less negative, and gets closer to zero, that would be considered depolarization. Now, even if the membrane potential continues to become positive, this whole change here is called depolarization. So again, if the membrane potential becomes less negative, that's considered depolarization. And if it goes over zero and becomes positive, that's still considered depolarization. Now, if the membrane potential gets depolarized, the membrane potential will go back down, become less positive and more negative. And if you're going back from a depolarized state, that's called repolarization. And if the membrane potential becomes more negative than it was at rest, and remember, the most negative it can get in this scenario here, this would be, let's say we're dealing with potassium channels, the most negative it can get would be the equilibrium potential for potassium. There is still some room here to get closer to EK, and that would be considered hyperpolarization. And these terms are going to be terms that we will use when we're talking about not only action potentials, but also effects of different neurotransmitters on neurons. Now, one final definition that we can talk about is a definition called the threshold potential. And by definition, the way we're going to do this is that this is what the membrane potential must be in order to trigger an action potential. And I want to be careful here with the wording. We're talking about overall the triggering of an action potential. We're not talking about a specific channel. And actually, the way that I think about this is if we're dealing with a sodium channel-based action potential, if you get to this number, whatever it is, that's going to open up a sufficient number of voltage-gated sodium channels, if that's the particular channel that is involved in the action potential. And if there's enough of them open together quickly enough, that will start this regenerative process called an action potential. So even though individual channels might have some different thresholds themselves to open, you're talking about getting to a place where you get enough of those channels open together quickly enough to make that happen.